one more thing, I mean, if you remember that while discussing Rutherford's model, he found out that the 99% of the atom is empty. Whatever weight is there is inside the nucleus. And who resides in the nucleus? Nucleons. What are nucleons? Protons and neutrons. So almost entire weight of an atom resides in nucleus, and that is nothing but weight of neutrons and protons. Now come again over here. If the atomic weight of zinc is 70 and its atomic number is 30, atomic number means number of protons, then what will be the atomic weight of zinc 2 plus? Now see, understand that thing. Atomic weight is always because of the neutrons and protons present. So it has given in the question, this is actually 70. Okay, now they are saying the atomic number is 30. So atomic number 30 actually means zinc. This atomic number 30 is the signature, it is a fingerprint of element zinc. Okay, now they are saying what will be the atomic weight of zinc 2 plus. So when I say zinc 2 plus, what is the meaning of that? That we have taken out 2 electrons. So what actually means? Number of protons will be 30 because we are not disturbing the nucleus. But number of electrons will be how much? It will be 28. That's why the total positive charge will be plus 2, because over here right now the number of protons are more than number of electrons. If number of electrons are also 30, then it will be zinc, neutral species. But since it is positive, that means the number of protons must be in excess as compared to number of electrons. So number of electrons have decreased. But do you think that by taking out 2 electrons, will there be any significant change in the atomic weight of zinc? No. And the reason being, whatever the weight is, it is because of number of neutrons and number of protons, which is 70. And I am not disturbing the number of neutrons and protons. I have simply taken out 2 electrons. So it is just again, if a truck is there, it is fully loaded with the pebbles, some thousands of pebbles, and if I take out 2 pebbles, will the weight of truck will change significantly? You will say no. So whatever the weight is, it is because of number of neutrons and protons, and I am not disturbing that. So atomic weight will not change. It will remain 70. The reason being, the number of neutrons and protons are still the same. So here what we have learned, that if you take out electrons, you take out n number of electrons, the weight of atom is not going to change. And the reason for that, the weight depends only on the number of protons and number of neutrons. I hope that is clear. So students, let us do this question. So what we are doing the questions, and while doing the questions we are also learning certain concepts which we have not covered in the theory part. So let's see that. This question says the mass number of 3 isotopes. Isotopes means, isotopes are the different atoms of the same element with different mass number but same atomic number of an element are 10, 12 and 14. So the mass number, what do you mean mass number? Atomic mass number, A units. Their percentage abundance is 80, 15, 5 respectively. Find the atomic weight of the element. Remember that whenever they are going to ask you these kind of questions, they give you certain number of isotopes which will be having different number of their mass numbers, and they will also give you the percentage of abundance. They are asking you atomic weight. This atomic weight is nothing but average atomic weight. Now what is average atomic weight? Very simple. What is average, by the way? Average is nothing but total weight upon total number of atoms present. Average is total weight upon total number of atoms present. Now let's see that. So whenever they give you percentage, it is always a good idea that you begin by 100. So what I will do, I'll divide their percentage now. So I'm assuming that let the total number of atoms of all the 3 isotopes combined is 100. Now out of that, the percentage or the number of atoms of the first isotope are 80. Number of atoms of second isotope will be 15, and number of atoms of the third isotope will be 5. So what I have assumed here, I am assuming that the total number of atoms of isotopes are 100. Why 100? Because they have given me percentage. So when you base your question on 100, the calculations will become very easy. So now out of 100, because of this information given, I can safely say that the number of atoms of the first isotope are 80, number of atoms of the second isotope are 15, and that of third is 5. Now their individual weight is how much? Atomic weight of the first isotope is 10, that of second is 12, and that of third one is 14. Is that clear? Now see, listen to me carefully. Now this is the weight of one atom of isotope. This is the weight of one atom of second isotope. This is the weight of one atom of third isotope. So how many atoms of the first isotope I am having? 80. So let me find out now the average atomic weight. Average atomic weight, students, is what? Total weight upon total number of atoms. So total number of atoms are 100. So total weight will be now the weight of all the atoms combined. So weight of one atom of this isotope is 10. How many of them are there? 80. So total weight of 80 atoms will be 80 into 10 plus weight of one atom of this isotope is 12. How many of them are there? 15. Weight of one atom is 15. Weight of 15 will be 15 into 12 plus weight of one atom of this isotope is 14. How many of them are there? 5. So it will be plus 5 into 14. Now you add them up and you will get the answer as 1050 divided by 100, and that will be 10.5. So you can see that though the atomic weights are pure integers, but the average atomic weight is in decimals, is in fractions. Why this is so? Because this element given in the question is having different isotopes. So when we find out the atomic weight of that element, it is nothing but average atomic weight. Average atomic weight normally are in fractions, in decimals, because many elements do exist in the different forms of their isotopes. So when you will take an average, you will find sometimes the answer is in decimal and fraction. So if someone is asking you why the average atomic weight is in decimal, it is because of the number of different isotopes which have different weights. So when you will take an average, many a times you will find that the answer will be in decimal. Okay. So let us do one question on a concept called isoelectronic. So this question says that the pair NH3 and BH3 boron hydride is isoelectronic with C2H6, B2H6, C2H4, CO2. Let us calculate that. Hai? So total number of electrons in NH3 and BH3 will be, so for this pair NH3 and BH3, total number of electrons will be, N contains how many electrons? 7. Hydrogen contains 1 electron. How many hydrogen are there? 3. So 7 plus 3, they are present in ammonia, plus in boron number of electrons are 5 plus 3. So total will be 7 plus 3, 10, and 10 and this will be 3. So and 7 plus 3 and 5 plus 3, 18. So total number of electrons are 18. Now let us find out the number of electrons in the each species. So for C2H6, now I know that in one carbon there are 6. How many carbons are there? 2. So in 2 carbon I will be having 2 into 6 plus 1 electron in 1 hydrogen. How many of them are there? 6. So plus 6. 12 plus 6 will have 18 electrons. Second option is B2H6. In boron, boron contains 5 electrons, 2 will contain 10. So 10 plus 6, total becomes 16 electrons. Now come to C2H4. One carbon contains 6, 2 will contain 12. One hydrogen contains 1, 4 will contain 4. 12 plus 4, 16 electrons. Fourth, CO2. One carbon contains 6, oxygen contains 8. There are 2 of them. So 8 plus 6, 14, 14 and 8, 22 electrons. So which species are like isoelectronic with NH3 and BH3? So we need 18 electrons. So which among these contains 18 electrons? Only C2H6. So C2H6 will be isoelectronic with this combination of ammonia and BH3. Okay, so students, let's solve a question based on Rutherford's alpha scattering experiment. So this question is saying that in alpha scattering experiment, which is incorrect. Remember that, which is incorrect, because I want you to focus more, because sometimes people do what? Rather than reading this as incorrect, they will read it as correct and they will mark a wrong option. So in Neet entrance examination, what actually happens, your knowledge is important, I'm not denying that, but more than that, what is important in entrance hall is your focus, is your concentration levels, that whatever you come across in the question, what is the question saying, what are the options, first of all, make a habit to read them right. We sometimes know what is the process, what is the experiment, but sometimes we miss out on that, because we have not read the words correctly. So first of all, you should be reading the questions correctly. If you read the question incorrectly, 100% you will be getting a negative mark, and that is a bit dangerous in terms of scoring. And also, please read the options very carefully. Take 2 more seconds, but give the correct answer. There is no point in reading quickly and reading incorrectly and giving a wrong answers. So you will become doctor not by attempting many questions. You will become doctor by attempting them right. So your focus is initially, or should be initially, doing questions right. Speed will come automatically once you start revising, practicing. The more you will practice, the more your ability to handle the questions will increase. You will become more efficient. But remember that apart from whatever you know, the focus and the concentration are the most important tool in the entrance hall. So please read the question correctly. So here what they're asking, which is incorrect. So let us find out which is incorrect. So before we go through the options, let us go with the Rutherford's alpha scattering experiment diagram. So it was, suppose, say atom, and it was nucleus, it was positively charged. So when the alpha rays were passed, you know that most of them they passed undeflected. Most of them, almost 99% of the rays passed undeflected, and it is because of this part Rutherford concluded that the most part of the atom should be empty. If it was not empty, alpha rays should have been stopped either, they should not have been passing through, undeflected otherwise. Now, few rays which were passing near the nucleus, they were deflected. And 1 in 10,000 or 1 in 20,000, in different books, this data is given different. That is not important. What is important is that only very few alpha rays were deflected back. Okay, so now we know this is the alpha scattering experiment. Now let us solve the question. First option, most alpha rays pass without deflection. Yes, most rays you can see they are passing without deflection. So this is correct. But this is not the answer. They are asking for incorrect. Incorrect. Okay, so I should be focusing on incorrect part. Second one, few alpha particles pass through nucleus. No particle passes through nucleus. The particle which is in the line of nucleus is deflected back. The reason being because alpha particles. What is this alpha particle? Alpha particle is nothing but a helium nucleus. It is nothing but helium nucleus with both its electron taken out. This is also positively charged. Nucleus is also positively charged. So they will repel heavily. Moreover, the nucleus of the gold is very, very heavy. Very heavy. So when a lighter object strikes with a heavier object, it will be deflected back. Here it is supplemented by the charge also. Okay, so it cannot pass through that, because we know that Rutherford found the density of nucleus is 10 to power of 14 gram per cc, staggering. It is impossible to pass through that easily. Okay, so this is incorrect and that should be my answer. So let me check out if other options are correct or not. So come over here. Few alpha particles are deflected back. Yes, very few particles are deflected back. That is also correct with regard to Rutherford's alpha scattering experiment. Coming to the fourth option, alpha particles going near the nucleus are slightly deflected. Going near the nucleus, they are slightly deflected. That is also correct. Okay, so 1, 3 and 4 are the correct statement. We are looking for incorrect statement, which is basically second. No alpha particle passes through nucleus. Okay, I hope this is clear now. So let's solve next question. So students, let's solve this question. In this question, I'll teach you that the given option might be right unto itself. That means there is nothing wrong with that statement. But that right statement might not be the right reason for the answer of this question. Understand that thing. A statement might be correct. Okay. But for example, sky is blue. That is correct. But this statement has got nothing to do with that this board is green. Why this board is green? The answer cannot be because the sky is blue. Okay. So there is nothing wrong with that statement. But we have to find out the right reason. We are not only looking for right statement, we are also looking for right reason of the answer. So let's do this question. In alpha scattering experiment, most alpha particles pass undeflected. We know that most alpha particles, they pass undeflected in alpha scattering experiment, and it is because of this Rutherford concluded that 99% of the atom is empty. So now let us look at the options given. So we have to hunt for the right answer. This says, first option says alpha particles are much heavier than electron. Yes, in alpha particles we have got 2 protons and 2 neutrons. 1 proton or 1 neutron is 1860 times heavier than 1 electron. So 4 will be much heavier. No doubt about it. So this statement is very correct. But this statement is not the answer of this question. Why? The reason is that the size of the atom, I told you that size of the atom or the radius of an atom is almost 1 lakh times more than the radius of the nucleus. And in this extra nuclear space, any space apart from nucleus is called extra nuclear space, and according to Rutherford experiment, electrons couldn't reside inside the nucleus, so they were supposed to reside in extra nucleus space or outside the nucleus. Now the fact is that these electrons are so sparsely located, they are very far apart. For example, if I take that Vijayawada is the nucleus. Okay, now 1 electron, if I go with the scaling, 1 electron will be in Hyderabad, 1 will be in Vizag, 1 will be in Kurnool, like that, 1 will be in Delhi. So they are very far. So if any object is coming, though the weight of electrons is very less, that is a different thing, but that probability of striking with these objects will be very less. So chances of alpha particles striking electrons is very less because the electrons are very sparsely located, very sparsely. If they were closely packed, densely located, in that case, they would have been successful in stopping alpha particles. How come? I'll give you an example. Suppose if I say there is a pebble in front of a moving truck, that pebble itself might not be able to stop the moving truck. But if I say we have a huge pile of pebbles, and if I ask a truck to pass through that, the truck will get stuck into that hill of pebbles. It might not be able to pass through that. The reason being, right now these pebbles are densely packed. So if I pack the electrons densely, they might stop the alpha particle, though each electron is very light as compared to the alpha particle weight. So that cannot be the answer. This statement is correct. Alpha particles are heavier than electron, yes, but that is not the right reason, because alpha particles will not have a chance of striking with multiple electrons at a time. Electrons are sparsely located, very far located. Okay, now come to the second option. Alpha particles are positively charged. Yes, they are positively charged, we know that, but that is not the right reason of them being deflected. So what I'm saying, suppose if we were having positive charge everywhere, in that case these alpha particles would have been deflected. Yes or no? But we know that since positively charged species are located only in a very small space called nucleus, and that nucleus is hardly 1% of the entire atom. So most of the alpha particles do not get the chance of moving near the nucleus. So that is correct, but not the right answer. If the question was like that, some of the alpha particles are deflected because alpha particles are positively charged, then this sentence would have been the correct answer of the question, that some alpha particles are deflected. Because alpha particles are positive, nucleus is also positive will repel. Okay, so I'm looking for my question. So this is also not the right answer, right reason, though both sentences are correct. Okay, now third one, alpha particles move with a high velocity. Yes, we are not denying that alpha particles move with very high velocity. But suppose I'm saying again, any bike, any car, if it is moving with very high speed, it can be stopped if it is coming against a wall. So moving at high speed is not the necessary and the sufficient condition for something to pass through. What I'm saying, though alpha particle is moving at very fast speed, but few alpha particles, when they strike nucleus, which is very densely packed, they are deflected back. Okay, they do not pass through that. If this entire atom was densely packed, they would all have been deflected back. The reason they are passing through, most of them passing through, is most of atom part is empty. There is nothing out there. So let me come to the fourth option. Most part of the atom is empty, and yes, that is my answer. They are passing because there is nothing out there. There is no obstacle for them to surmount. They can pass out easily because most part of the atom is empty. So in this question we have learned that the given statements might be right, but they may not be my right answer. Okay, so please focus on the right reason also, apart from looking for the right sentence. Is that okay? So this question, students, is going to check your memory, how much concentrated you were while doing the theory part. So according to alpha scattering experiment, which is or are correct? First one, the density of nucleus is 10 to power of 14 gram per cc. Is this correct? Yes, it is correct, because he came to conclude that nucleus is very densely packed species. So this sentence is actually correct. The order of the density of nucleus is 10 to power of 14 gram per cc. Now second option is radius of atom upon radius of nucleus is almost equal to 10 to power of 5. So yeah, I told you that the radius of an atom is almost 1 lakh times bigger than the radius of the nucleus. That actually means 99% of the atom is empty. Okay, so this is also correct. So this is correct. This is correct. Scattering follows Coulomb's law. So that means the scattering of alpha particles, the dispersal of alpha particles, it is all because of what? Electrostatic repulsion. And any force called electrostatic in nature is called Coulomb's law. Yes, they follow the Coulomb's law also, because here we are involving the scattering or the deviation. This is because of electrostatic repulsion, which follows, yes, Coulomb's law of electricity. This is also correct. Nucleus move with a high speed. Now, there was nothing conclusive which Rutherford could find from this experiment that nucleus moves at very high speed. He couldn't conclude that. There was no evidence that nucleus is moving at high speed. He was only able to conclude that if he want his model to be stable, the only way he could save his model by putting electron outside was that he said that electrons should be moving, just like the planets are moving around the sun. What will happen with that? This centripetal force will be equal to centrifugal force, because we have read that in the mechanics, in the planetary motions. So because of this balance of force, planet motion around the sun without falling inside the sun. But according to electromagnetic theory, the accelerated particles will lose the energy in the form of electromagnetic radiation, and it will soon fall into the nucleus. It was because of this electromagnetic wave theory that Rutherford's model couldn't stand correct. I hope this is clear. So this is incorrect, rest 3 are correct. So students, let us solve a question on cathode rays. See that. They're saying which is not correct. Again, this is important, not correct. Sometimes people do read what? Which is correct, and they gave a wrong answer in hurry. Okay, so which is not correct regarding cathode rays? The first sentence, they originate from cathode. Yes, we have learned that the cathode rays, they originate from cathode, they move from cathode towards anode. If you remember that, this was like cathode ray tube, and this was our cathode, and this was our anode. So when we applied the battery a high voltage, the cathode ray was moving from cathode to anode, the positive terminal, towards the fluorescent screen. So it is definitely originating from cathode. That's why they are called cathode rays. So this is correct. We are looking for not correct. Their charge upon mass ratio depends on nature of gas. Now cathode rays are nothing but electron. So if you remember that there was a gas inside this chamber, and when the charge bars or the electric potential was applied, the gas is ionized. So what happened? Suppose I'm talking about neon. So neon will ionize to give you neon plus and a electron. Now for any atom, any element, the electron is the fundamental particle. It is same in every element. So its charge upon mass ratio is independent of the gas. You take neon, you take hydrogen, you take helium. I mean, they will all give electrons which are identical in nature. Their mass is same and their charge is also same. Their charge is 1.6 10 to power of minus 19 coulomb, and their mass is 9.1 10 to power of minus 31 kg. So the charge upon mass ratio for cathode rays particles is same. But remember that the charge upon mass ratio is not same for the cation of the gas. So for anode rays, charge upon mass ratio is not same. It will vary from gas to gas. For example, if I take say neon plus, if I take say H plus, so you can see that the charge upon mass ratio in terms of unit. So 1 unit positive charge 1 upon the mass of neon 20. For hydrogen, 1 unit of positive charge upon mass of hydrogen 1. So it is 1 by 1 for hydrogen gas, and it is 1 by 20 for neon. I hope that is clear. Now see that charge upon mass depends on nature of gas. This is incorrect. This is incorrect. I'm looking for incorrect answer. So that will be the right answer. Let us further see the other options. Maybe they be wrong or right. So charge upon mass ratio is independent of the material of the cathode. Yes, it is independent. You take any metal, you can take say aluminium, silver, whatever you take. Cathode rays are made up of electron, and all electrons are the fundamental particles. They stay same in every element. So yes, the charge upon mass is independent of the material of the cathode. That is correct one. Their charge upon mass ratio is more than that of anode rays. Charge upon mass ratio is more than that of anode rays. Yes, because every gas is composed of neutrons and protons, which are very heavy. So if I take, suppose say, neon plus, and I take, suppose say, electron, so the unit charge is, suppose say, 1, the mass is 1 by say 20 protons and neutrons, but for electron the charge is 1, but you know that the weight of electron is basically 1 by 860 times that of neutron or proton. So it will be like 1 upon 1860. So this will be almost 1860, this ratio, which is very high. The charge upon mass ratio of electron is very high because mass of electron is very less. Because of that, the ratio becomes very high. I hope that is clear. So the charge upon mass ratio of cathode rays is more than anode rays. This statement is also correct, but we are looking for incorrect statement. So we can safely say that charge upon mass ratio, it does not depend on nature of gas. Here it is written charge upon mass ratio depends on nature of gas, which is incorrect statement. So my answer will be the second one. I hope that is clear. So students, that will be the end of the session today. So please keep revising whatever we have done. Don't leave the work on pending mode, because when you put the work on pending mode, it becomes a pile and it is very difficult to revise and get more marks. So please keep on doing the revision, keep on practicing the questions, and keep on reading the theory properly. Command your concepts and then accordingly do the questions on that. Doing questions will always help you in polishing your analytical skills, your logical skills, which are very, very important from the point of view of Neet. So we'll meet next time with more questions and some other concepts. Till then, take care and keep studying. Bye-bye.